chapter 5. Now we are going to start proving, we're going back to some of our proofs, triangle congruence with side, 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 and side, angle, side relationships. Okay, so let's revisit congruent triangles. Remember, congruent triangles, that they are congruent if they have the same size and same shape. In other words, they must have three pairs of corresponding congruent sides and three pairs of corresponding congruent angles. Now, that is what it means to be congruent triangles. However, there are some shortcuts that we know will also work to knowing if triangles are congruent. We're going to be learning 4 of them over the next 2 days. So today we're going to learn the first 2. The first one is side, side, side. Now, what that simply means is if I know that I have one side, corresponding sides congruent, I have a second corresponding set of corresponding sides congruent, and I have a third corresponding sides congruent, then what that tells me is that these two triangles would be congruent. Okay? Now, how you write that congruence is very important. So I'm going to start over here and I'm going to go triangle ABC is congruent to triangle. So now we need to make sure that we match up. We're going from A to B, and that is from the 1 congruent side to the 2 tick mark side. So that would be ZXY. Okay? Because A is matching up to Z, B is matching up to X, and C is matching up to Y. So remember, we have to be very careful there of how we write that congruence. And we know those are congruent by side, side, side relationship. Okay, let's go to the second one we're going to talk about today. This one is called side, angle, side. So again, we know that one pair of our corresponding sides are congruent. We know that a second pair of corresponding sides are congruent. Now, on this third one, this one is so important. The angle between those congruent sides, we call that an included angle. Okay? So it is the included angle between the two corresponding sides that are congruent. If we know that, then we can say these two triangles are congruent by side, angle, side. So we could write a congruent statement like, for example, CAB is congruent to triangle. Now we need to make sure we match it up. B is definitely matching up with E. C is matching up with F. And D is matching up with A. So you have to make sure that you have those together. The key here is on this rule, side, angle, side, that the angle has to be the angle between the two corresponding sides that you know are congruent. Okay, so use side, side, side or side, angle, side to say if the triangles are congruent. Otherwise, state not enough information. So let's take a look. Do we know a corresponding side is congruent? Yes. Do we know a second corresponding side is congruent? Yes. And thirdly, do I have the angle congruent between them? And the answer is yes. So this one would be congruent by side, angle, side. Okay, let's look at the second one over here. Do I have a side corresponding sides congruent? Yes. Do I have a second pair? Yes. Do I have a third pair? Yes. So therefore, this one would be congruent by side, side, side. Okay, let's try the next set. So, do I have a pair that is congruent? Yes, I have one of my correspondings. Do I have a second one? Yes. But if you think of these two rules, I need either a third side or an angle between them. Well, is it possible to get an angle between those two sides? And the answer is yes, because we know that this angle would have to be congruent to that angle because they are vertical angles. Okay, so since those are vertical angles, we know that those two triangles would have to be congruent by side angle side. All right, let's take a look at this one. So here again, we start off, we're just checking off things. Do I have one set? Yep, I have one set. Do I have a second set? Yes, I do. Do I have a third set, either a third side or an angle that I can say is congruent? Well, the problem is I don't have a angle that I can say, but due to the reflexive property, I'm going to write that here, due to the reflexive property, we know that this side has to be congruent to itself. So therefore, we know this triangle, these two triangles are congruent by side, side, side. All right, let's try two more here. So we start off again. Do I know one pair? Yep. Do I know a second pair? Yes. So now we go to the third thing. I either need the angle between them or I need the side. And on this one, I cannot decide that, so this would be not enough info. They may or they may not be, but we just don't know that. Okay, let's go to this last one. So on this last one here, do I know one pair of corresponding sides are congruent? You bet. Do I know a second pair of corresponding sides congruent? You bet. Do I know a third pair of corresponding sides? And I don't. Do I know an angle that would be congruent? And I do. These are congruent because they make a vertical. Oh my goodness. Sorry about that. Okay? They make vertical angles. So since those make vertical angles, but we have a problem. Notice they are not the included angle. It is an excluded angle. The angle that we would need to have congruent would have to be this angle here and that angle there, but we don't. So this is not enough info. Okay, that's now going to lead us into writing some proofs now. So what we're going to do is we want to prove that MGK, I'm going to highlight this one, that this triangle is congruent to RGK. Now, when we look at this, we need to start marking up our figures. This is where I told you from the get-go, it is in your best interest to mark up your figures so that you can see what you know and what you don't know. So let's start in with our given statement. The first thing I am told is I'm told that GR and GM are congruent. That is my given. I'm also told that K is a midpoint of RM. Okay? Now, we have to think about this because we need either three sides, three sets of corresponding sides congruent, or we need two sets of corresponding sides and the included angle in between them. Now, when I first look at this, I can tell you right now, I'm probably not going to be able to get an angle. There's nothing given to me about an angle. It's going to be hard to find an angle that is congruent. So instead, I'm going to go for side, side, side. All right, so here we go. The next thing I know is I know that MK is going to be congruent to RK. How do I know that? Because that is the midpoint theorem. Remember, if K is the midpoint, then the two segments are congruent to each other. So MK is congruent to RK through the midpoint theorem. Next, I also know that GK is congruent to GK, and that is because of the reflexive property. Because one line is always congruent to itself. Okay, so now if you look at this, here's what we have. We have this side congruent, this side congruent, and this side congruent. So we have three sides. So now I know that triangle MGK must be congruent to triangle RGK by side-side-side relationship. Okay, let's try another one here. So this time I'm wanting to prove triangle AHB is congruent to triangle LCB. I know that AL bisects HC. So what I would know is that I can get this to this. I also know that HC bisects AL, so I know I can get those two. Now, if you think about it, will I be able to get a third side? And the answer would be no here, but I should be able to get these two angles congruent because they're vertical angles. So let's go through the proving process now. So the first thing I know is I know that AB is going to be congruent to LB. And be careful how you're writing that. Remember, order matters here. So AB is congruent to LB, and that is by segment bisector. Then I also know that CB is congruent to HB. Again, by segment bisector. Then I know that angle HBA is congruent to angle CBL. And I know that by the vertical angles are congruent. Now I have two sides. Here's side one, here's side two, and the included angle. So now I know that triangle AHB is congruent to triangle LCB, and that is by the side angle side relationship. All right, let's try one more here. Let's see what we can do. So we know that BC is congruent to AD. We also know that BC is parallel to AD. Now, if we're thinking ahead here, I'm looking for things that I can also get. Well, I know that I can probably do something with the AC side or the CA side. Okay, I'm wanting to prove ABC is congruent to CDA. Okay, so ABC is congruent to CDA. All right, so what do I know then? So here we go. Let's start in. So let's just do the AC right off the bat. Now, if you notice the way that they're writing it, that's telling me something. That AC is not congruent to AC, but that AC is congruent to CA, and that is the symmetric property. Because it's not identical, it flips the order there. Now, this might go back a little ways, but if you look at this drawing, you have two parallel lines cut by a transversal AC, and that would make the alternate interior angles congruent. So your next statement is going to come in here and you're going to say angle DAC is congruent to angle BCA, and that is by the alternate interior angle theorem. Okay, so now we have, as we go through, here's side 1, here's side 2, and we have the included angle. So therefore, we know triangle ABC is congruent to triangle CDA. And how do we know that? Because side angle side relationship. All right, and that is how we start off on day 1 with side, side, and side angle side relationships to prove triangle congruence.